Hello viewers, Moments question 6, and for the first time we encounter a UDL. We see on the left hand of the beam, directly over A, we have a 5 kilonewton per metre block. And the first thing we need to work out is its length. So the length of the UDL, we need to work out. Okay, so we see that there's a 1 metre overhang. It extends 1 metre to the left of A. We also need to work out how far it goes to the right of A. We see that there are 10 metres between the two supports, and there are 5 metres between the right hand end of the UDL and B, and therefore this dimension here must be 5 metres. The whole UDL must therefore be 6 metres long. And the force is going to be, we now know it's 6 metres, multiply that by the 5 kilonewtons per metre, and we get a force of 30 kilonewtons. So we've turned it into a single force. Now we need to work out where that force is. So the weight of a UDL can always be taken to act through its centre. We know that it's 6 metres long, so its centre must be 3 metres along. So 3 metres from the, let's say, the far left-hand end of the UDL. Because we've got that 1 metre overhang beyond A, that means that 3 metres from the edge of the UDL would be 2 metres to the right of A. So we have effectively got a 30 kilonewton force acting 2 metres to the right of A. So now that we've turned that into a single force acting at a single location, it is exactly the same kind of thing as we did in the previous questions from here on. So we need to say sum of the moments is 0. Let's say A is our pivot, and let's take clockwise to be the positive direction. So we're taking moments about A. We have a 30 kilonewton force, which is 2 metres away from A. We also have an 8 kilonewton force, which is how far from A is that. So we've got 5 metres up to the end of the UDL, plus another 2 metres, so that's 7 metres. Now, the support force at B is going to provide us with an anti-clockwise moment, so therefore we've got a minus. So we've got B is the force, 10 is the distance, equals 0. So therefore 30 times 2 is 60, 8 times 7 is 56, equals 10B if we move that to the other side. So 60 plus 56 is 116, equals 10B, and therefore B is 116 divided by 10, so therefore we have B is 11.6 kilonewtons. So we have B. Now we need to use sum of the forces equals 0, second condition of equilibrium, and we're going to take upwards to be the positive direction. So the up forces are A and B, and the down forces are 30 kilonewtons and 8 kilonewtons. So therefore, we already know B, so we're finding A, which is 38, is the minus 30 minus 8 moved to the other side, minus 11.6, and if we calculate that, we get 26.4 kilonewtons. Okay, thanks for watching. Over and out.